So we can see that the action and reaction forces, they are acting on two different bodies and their line of application is same. We can also derive Newton's third law mathematically. To do this, let's take an example. Suppose we have two blocks, block A and block B. Block A exerts a force FAB on block B, and block B exerts a force FBA on block A. Let's take a system consisting of block A and B. So we have this system and block A and B are part of it. So in this system there is no external force. These two forces, that is FAB and FBA, these two forces are internal to the system. So now, since there is a force FBA acting on block A, so the change of momentum caused by the force FBA in a time interval delta t would be delta PA is equal to FBA into delta t, where delta PA is the change of momentum in block A. Similarly, change of momentum of block B because of the force FAB would be delta PB is equal to FAB into delta T. Since our system consists of both block A and block B, so the total change in momentum of the system, that is delta P system, would be change in momentum of block A, that is delta PA, and change in momentum of block B, that is delta PB. So delta P system would be FBA into delta T plus FAB into delta T. Since there is no external force, we have this equation that F external is equal to dP system by dt. Here we don't have any external force acting on the system, so F external is 0, which means that dP system by dt is also equal to 0, which means that delta P system is equal to 0, and delta P system was FBA delta T plus FAB delta T. So this implies that FBA plus FAB is equal to 0, or FBA is equal to minus FAB. So we can see from here that the magnitude of these two forces, that is FBA and FAB, are equal. And since FBA is negative of FAB, which means that both these two forces are acting in opposite direction. This is how we can derive Newton's third law mathematically. Now let's see what is an external force and what is an internal force. A force is said to be external if its reaction is applied on an object which is placed outside the system. To understand it, let's take an example. Suppose there are three blocks, block A, block B and block C. Block A and B are part of a system. Let's denote this system by system 1, and block C is part of another system which is system 2. Now we need to find out if an force is being applied on system 1, whether that force is external or internal to the system 1. So suppose block C exerts a force F1 on block A. According to Newton's third law, block A will also exert a force F2 on block C, and such that F1 is equal to minus of F2. Now to find out whether the force acting on system 1, that is F1, whether this force is external or internal. So again we can get back to this definition. It says that a force is said to be external if its reaction is applied on an object placed outside the system. So the reaction of force F1 is F2, which is being applied on block C, and block C is not part of system 1. So this implies that F1 is external force on system 1. Let's come to internal force now. A force pair is internal if both action and reaction act on the objects of the same system. So again, if we take the same example, so here we have block A and block B, and block A and block B are part of system. So suppose if block A exerts a force FAB on block B, and block B exerts the reaction force FBA on block A. Here FAB is equal to minus of FBA. So here both the action force, which is FAB, and the reaction force, which is FBA, these are being acted on the object of the same system. So these two forces, that is FAB and FBA, they are internal forces. Finally, let's talk about Newton's first law. Newton's first law is also called